All right, so for the remainder of this chapter, we're going to be talking about how to confer charge from one object to another. So the transfer of charge using static electricity. Probably the most familiar with charge is charging by friction, where electrons are transferred from one object to another by friction. Think of the clothes tumbling around in the dryer, the clothes dryer. As they're getting more and more dry, they're conferring charge one to the other, and then they cling to each other. Okay, that's charge by friction. The lab you're going to view, a fur pelt will be, or a cloth can be rubbed on either a rubber rod or a glass rod or a comb, and then a charge is conferred from the cloth or fur to the rod. So if the rod has a net charge, then so does the cloth. So you'll see objects that will dance around and be attracted to something like a comb or a glass rod. And you can see what's interesting, even though they have opposite charges, the bits of paper, which are neutral, behave similarly. Okay, and we'll talk about why in a minute. So here we have a kind of a cartoon. We have must be Valentine's Day. This couple on a date. Love is in the air. She slides across the chair, and unbeknownst to them, as she slides across the chair, she is becoming charged by friction between her and the chair. Okay. Then they kiss, and sparks fly. And I'm sorry, it's not because of love. It's because of contact, charging by contact. So if she becomes charged and she has a different charge than him, then their contact or near contact can cause a discharge of static electricity. Much the same way as when you walk across a carpeted floor on a dry day and then touch a doorknob and get a shock. You're charging by contact. Okay, the most tricky is charging by induction. You can induce a charge not by touching it, not by frictioning it, but merely by bringing a charge next to it. So here we have an illustration. We have two metal spheres. They're on an insulated base, and you can see that they're touching. And then a negatively charged rod is brought near these metal spheres. And this negatively charged rod will repel at least a sum of negative charges away from it, so that the excuse me, the sphere on the right has a net negative charge relative to the sphere on the left. Then if you pull them apart while this rod is still there, then you can see that the net charges remain. So now we have a sphere that is net has a net positive charge versus a net negative charge relative to each other. So if you were to bring something that was hung on a string next to this A sphere, it would behave differently than if it were hung next to this B sphere because they have an opposite charge. And this never touched either of them. Okay, and you'll see this happen in the lab you're going to view. So here's another illustration of charging by induction. So we have a metal ball hanging up from a string, and then we bring a negatively charged rod near it. And so it induces a charge to it. And because of the induced charge, the ball then swings towards the rod. And because this end is induced to be positive and this is negative, the ball sticks to the rod. Then if you touch the sphere, the negative charge will trickle. You're grounded, so it will trickle away from the ball. Then if you let go of the ball, now the ball is positively charged, the rod is negatively charged, so they'll just outright attract. And then when they touch, then there will be a charge conferred to the metal ball, and now they're both negatively charged, and then the ball will fly away from the um, negatively charged rod. Okay. So the most common natural phenomenon involving charge induction, it happens thousands and thousands of times each day, is the production of lightning. Lightning is one of the most common natural phenomenon on Earth. It happens way more often than we realize. So in essence, the ground is induced with electrical storms. The ground is induced to have a net positive charge, and the cloud is induced to have positive on the top of the cloud, negative on the bottom of the cloud. And if enough difference of electrical potential builds up, then you can get a discharge. Okay. Now, everybody knows about a lightning rod. They know the shape of a lightning rod. They know where you put a lightning rod. But what they don't realize is the role of a lightning rod. Most people think that the role of a lightning rod is to attract lightning, which it certainly will do, but its main role is to prevent lightning. It's to prevent the buildup of charge on the ground, so that lightning won't strike. So who invented the lightning rod? He invented quite a few things. Yep, you're right. It was Ben Franklin. Other inventions: bifocals, fire insurance, numerous other things. The Franklin stove, which is a metal stove. Instead of having a fireplace that all the heat goes up the chimney, why not make a stove out of metal so that it radiates out in the room? Okay, trivia question. How many lightning strikes are there per day on Earth? 1,000? A million? There are 10 strikes per second. So pause the video, figure out how many that is. 10 times 60 times 60 times 24. Yeah, I forget how many. It's like 86,000 or something like that. Okay, then the third way we're going to look at transfer of charge is charge by polarization. So that's where the surface of an insulator becomes slightly polarized and consequently attracted to a charged object. So this is what was happening when a charge was induced by that negatively charged rod held next to one of the objects we discussed. But those were with conductors. This would happen if you held it up to, say, a balloon or to the wall, something that is an insulator that's not going to actually transfer the electrons. It's just going to, excuse me. So here's what's happening that's at the atomic level. The electron cloud is kind of being warped by the induction of the electric field. Okay, so then if you think in mass of all the atoms that are in that insulator, that same polarity is being induced. Okay, so in the lab that you're going to watch, you'll see objects that are being charged positively, charged negatively. They're both insulators, and they're being held over objects that are also insulators. So this charge can induce a polarization in the material that it's interacting with. So you can try this at home. If you take a balloon and rub it on your hair and then hold it next to a wall, it will stick to the wall and it will stay there, because the negative charge of the surface of the balloon will induce a polarity in the atoms of the substances in the wall, and that the polarity will be relatively permanent as long as the balloon is there. Okay, so enjoy the video demo labs.